Good morning. My name is Philip. It is my great pleasure to be here today for this talk, Automatic Discovery of Interesting Patterns in Data. I am a professor at the Shenzhen University in China. So, first, I would like to say thank you for this invitation, especially to Professor Debnath Bhattacharya from the KL deemed to be university, and also to the staff from the conference. I'm very happy to see the continuous success of the SMART DSC series of conference that I've been following in the last few years. I have been seeing the success every year, actually. So it is the 5th edition already, and I think this deserves a big congratulations. I'm also happy this year to participate in the committee for the conference. It is a great honor for me, so thank you again. So briefly, to introduce myself, I'm Associate Editor-in-Chief of a journal called Data Science and Pattern Recognition. Before, I also serve as Associate Editor-in-Chief of Applied Intelligence, another journal. I'm a national talent in China, and I do the research on data mining, pattern mining, and the applications of data mining also. I work at the Shenzhen University. I changed recently. It is in Shenzhen, the city. It is not very far from Hong Kong, if you know a little bit about this, in the south of China. It is very hot weather, a very nice place. Maybe you have a chance to come visit me also. You are welcome. Okay, so in 2019, I've been to India. This is very significant for me. It was my last trip abroad before the pandemic, for the COVID, right? So, and I spent a few weeks in India. I went to Bangalore, Hyderabad. I give some talk at IIT, also RK Valley, Ahmedabad also for some conference. And also most importantly, I met a lot of great people. I have very, very good memory of my trip to India. And also gave some online talk at the KL University in 2020. And I hope when the conditions are better for traveling, I hope I can come back to India, maybe for the SMART DSC, maybe another year, I can come in person. Okay, so to give you some introduction for my talk, nowadays we talk a lot about artificial intelligence. Artificial intelligence or intelligence systems are used for many industries, like for education, healthcare, telecommunication network, industrial systems, and so on. So, if we want to build the intelligence systems, we need some data. The data is very important to train these systems. If you want to train the AI model and so on. And also, not only this, but the systems will also produce a lot of data. For example, the usage log, the alarm log, the fault log from the system, or the sensor data. Let's say you have a car, there's a lot of sensors, or your cell phone, and so on. And also the data exchange between the different systems. So we have a lot of data. Okay, so if you have a lot of data, it is great. Nowadays, we have data everywhere, for the government, for the businesses, and so on. And I think a lot of data in databases is good, but there's a need to understand the data. Even you have a lot of data, if you don't know how to understand, how to take advantage of this data, it is useless in some way, okay? So, in the past, when we had the small database, we could analyze the data by hand, maybe, okay? But nowadays, if you have millions of transactions in a store, for example, You need to use some algorithms to analyze the data for you. So one popular domain nowadays is the machine learning. Machine learning, like the deep neural networks and so on, will help you to build some models that can make some very good predictions, for example. But one problem about this is that a lot of machine learning models are the black box. That means you can train a network to do neural networks to do prediction very well, very accurate. But maybe you don't understand why it works, okay? Or it will not help you to understand the data as a human, okay? So it is very good for prediction and so on, but not so much for understanding. So today I want to talk to you about one subfield in data mining we call the pattern mining. The idea is not to beat the machine learning algorithm because they are very good, okay? But instead, the goal is to look at the data to find patterns. So we call this pattern mining because we want to find patterns in the data. And these patterns should give you some valuable knowledge about something new, okay? Something you can understand to take decision. And that is interpretable by the human. It's not a black box. So if you want to analyze the data, there are various types of patterns you can look for in the data, like the item set. Item set means, for example, some sets of values appear many times together in the database. Like for shopping, many people buy the bread and the milk together and so on, okay? Or other types of patterns. I will talk to you more about this later. Okay, another example. If we look at the data from the computer network, we can find, for example, a pattern like this, a rule. If there's a fault in computer A, there's 60% probability that it will be followed by a fault in computer B. The computer B will shut down, okay? So if you find this pattern in your data, it is easy to understand. You can learn something from this. Even you can go to do the maintenance of computer A to try to fix the problem in computer B and so on, okay? So it has a real meaning. Okay, so we want to find patterns in the data, but in what kind of data we can do this? So there are different types of data, like the relational databases, the graphs, the text, the spatial data, the sequences, the time series, and so on. But today I will talk to you about some simple case, okay? About shopping, what we call the transaction database. What the people buy in a store when they go shopping. So let's take some example to help me to explain. What is a transaction database? Okay, so let's say we have a set of items in a store, A, B, C, D, E. So I use the example of shopping, but it could be applied to other things, okay? So A in my example is for apple, B for bread, C for cake, D for dates, and E for eggs. Then we have a transaction database. It is a set of transactions. Each line in the table is a transaction. We call them T1, T2, T3, T4. The transaction T1 means some people bought A, B, C, D, E in the store. Apple, bread, cake, D for dates, and E for eggs. Transaction 2 means A, B, E, like apple, bread, and eggs, and so on, okay? So we have the data like this about shopping, and we want to analyze to find some interesting patterns. Will tell us something about our data. So how to find the patterns in general, okay? If you want to find patterns in your data, there can be millions of patterns. If you want to find the interesting patterns in your data, you need to define what does it mean interesting. So we need to find a way to calculate what is an interesting pattern. We need to define in a formal way. Okay. So there are many definitions of what is interesting, like the support. Support means the number of times something appears in your data. So maybe you want to find the products many people buy together often, okay, many times. So this is the support. Or maybe you want to find what makes the most money. This is the utility, okay. So the products people buy make a lot of money, and so on. So we need to first define what we want to find. And then after this, we need to design some efficient algorithm to find the patterns that we want. So first we define some constraint on what we want to search in the data. Then we use some algorithm to find exactly what we want that meet our constraints. So in general, there will be different algorithms to find different things in your data. Now I want to talk to you first as a very classical problem in data mining. It is the frequent pattern mining. It was proposed by two Indian researchers, Agrawal and Srikant. Okay. So let me explain you this with an example. Okay. Here I have a database on the left about shopping, as I have shown to you before. And then we want to find the frequent item sets. That means the sets of products that many people buy together. So we need to set a parameter called the minimum support, min sup. Okay. Here I set the parameter to 2. That means I want to find what the people buy together at least 2 times, at least twice. So the result is what you can see on the table on the right. For example, A appear 4 times. 4, the support. Okay. Support means how many times. So A appear 4 times in transaction 1, 2, 3, 4 on the left. AB appear 3 times. So it is also frequent item set because 3 is at least 2. So AB, if we look on the left, appear in T1, T2, and T4. So this is the basic idea about this problem. Okay, we can use this for shopping and also for many other things, but here I talk about shopping for today. So how can we solve this type of problems if you want to find the frequent item set in your data? There is a naive approach. That means simple. The naive approach is to scan the database to count the frequency of each possible item set, like A, apple, AB, apple and bread, AC, apple and cake, AD, AE, ABC, ABD, ABE, and so on. So all the possible combinations. But as you will observe, there are many combinations. In general, if we have n items, there are 2 to the power of n minus 1 possible item sets. So in my example, I only have 5 items, A, B, C, D, E. So there are 31 possibilities. But if you have 500 items in your store, there will be a very big number of possibilities, as you can see at the bottom of this slide. So we cannot use the naive approach. It will take too much time to look at all the possibilities. So how to solve that problem in a more efficient way? So there is a very famous property that was proposed. Okay, is called the Apriori property or anti-monotonicity. So what does it say? Okay, if you have two item set X and Y, and X is a subset of Y, then the support of Y must be no greater than the support of X. Okay, so maybe not so clear. So let me explain this with an example. It will be clear. So let's say we take AB as example. AB appears 3 times in the database. The support is 3. The properties say if you have a superset of AB, like ABC, it is impossible that ABC appear more than 3 times. So actually it makes sense. If there are 3 persons who bought AB together, it is impossible that there are 4 persons that buy ABC together, okay? Because ABC has more items. So this is what we call the anti-monotonicity or a priori property. And this property is very important. If you know AB appear 3 times, then you want to find the item set appear at least 4 times. You don't need to check any item set with AB because they cannot appear more than 3 times. And then you can save a lot of times. You don't need to look at all the combinations. So this is the main idea to solve this type of problems. Now, I want to talk to you about some limitations of this problem. The first limitation is many frequent patterns are uninteresting. If you look at shopping data, for example, maybe you find that bread and milk, many people buy this together. But maybe it is true, okay? But bread and milk don't make a lot of profit maybe for the business. And another limitation is that we don't have information about the quantities of item. If you buy 1 bread or 10 breads or 20 breads, it is the same thing, okay? In this problem, we only know you buy or not. We don't know how many. And also, all items are considered to be equally important. That means if you buy a bread or you buy a diamond, it is considered to be the same. But of course it is not, okay? If someone buy a diamond, it will make more money for the business. So there was a new problem that has been proposed that is popular these days. It is called the high utility item set mining. Utility means, for example, the money, okay? We want to find the sets of items that make a lot of money or profit for the store. So let me show you directly with some example how it works. Here I have the input for this problem. On the left I have again a transaction database. But here it is a little bit different than what I have shown to you before. So let's look at the first transaction, T1, the first line on the left, the table on the left. I have A1. So here I have a number 1. 1 means the quantity, like 1 apple. Then I have B5, like 5 breads. C1 means 1 cake. D3 means 3 dates. E1, 1 egg, and so on. Okay. So the difference with before, now we have the quantities, okay, in this table. And also we have something new. On the right you can see a new table. It is the unit profit table. So this table tells you if you sell 1 apple, you have A5, okay. A5 means you sell 1 apple, it makes $5 profit. If you sell one bread, we have B2. B2 means one bread is a $2 profit, and so on. So this is more realistic. Now, for this problem, we need to set a parameter called the minimum utility, or min util. So it means a minimum amount of money, okay? So the output will be like this. Let's say I set the minimum utility to $33. It means I want to find everything people buy together that make at least $33 of money as a profit. So for example, we find that BDE together make $36 profit. BCD make 34 and so on. It is at least 33. So we call this the high utility item sets. The item sets make a lot of money. Okay, so I did not explain how to calculate the money. So now I want to give you a little bit more details so you understand the main idea about this. Then I will talk to you about some new problems and extension and some research we did related to this. Okay, so how to calculate the utility, the money? Let's say we take BDE as example. BDE means we buy BDE together. They must be together, okay? So BDE appear in T1 and T2 on the table on the left. In T1, the transaction 1, we have B5, okay? That means 5 bread. On the table on the right, we can see that the bread is a $2. We have B2. So we do 5 multiplied by 2, okay? This is the money for the bread in transaction 1. If we continue in transaction 1, we have D3, okay? So 3 dates. And if we look the table on the right, the dates is a $2 profit. So 3 multiplied by 2, okay? Now after this, in T1, we have the egg, E1, 1 egg. The table on the right say the eggs is a $3 profit, so we have 3 multiplied by 1. So this is the money in T1. Then we do the same for T2, and we get the total, $36, okay? So this is how we calculate the utility. Now I want to show you why this problem is difficult. One problem here, it is that the utility is not monotonic or anti-monotonic. So what does it mean? Okay, in a simple way, it means that, let's say we take an example. We look at BDE. BDE, the utility is $36, okay? So if you take BDE, it means the superset of BDE, like BCDE, can make more money, like $40. But also, the superset of BDE, like ABCDEF, could make less money than BDE. So we don't know, okay? So what I want to say, okay, again, if you have an item set like BDE, you don't know the superset will make more or less money. It is not like the support I talked to you before, okay? So why is it like this? Okay, so if you look at BDE and BCDE, BCDE make more money probably because BCDE you buy more things together. So you think it will make more money because you buy more things. But ABCDEF make less money. Why? It is because there are less people that buy ABCDEF. So the more items you have, maybe less people will buy, and it will decrease the money. Okay, so this is the main reason why this problem is not easy. Now, how to solve the problem? There are many algorithms that have been proposed. The algorithms in green, like FHM, ULB minor, and so on, is proposed by myself. Okay. So the key idea how to solve the problem, the utility is not monotonic or anti-monotonic. So we will use some upper bound on the utility that will respect the a priori property. And this will allow us to reduce the search and to make the fast algorithm. Okay, so today I will not go into these details. I just want to give you some overview, okay, to show you some interesting problems related to this. So all of this is useful, but one limitation is that we don't consider the time. But if you look at the customers in a store, you will see that the behavior of the customers will change over time. So the time dimension is very important. Maybe some items will become more or less popular, or there will be some other changes over time. So let me show you some interesting problems we can study when we include the time dimension. Okay, so in one paper we did an algorithm to find the recent high utility item sets. So recent means we want to find the sets of products that made a lot of money but recently. Okay, so here I show you a picture to illustrate this. Here we have the utility, like the money, and we have the time. So this is for a products, some product like the apple, for example, or the bread. So we can see over time in this example the money will change. Maybe people buy more or less apples and so on. But here we want to find the products recently made a lot of money. So like in this picture we see the curve is increasing actually, okay, the line. So how to do this? In this paper we use a decay function to give more importance to what happened recently than what happened a long time ago. This is how we solve the problem. Okay, so today I will not go into details, I'll just give you some overview. Another paper we did about the time in high utility item set mining is to find the concept drift. So what does it mean, concept drift? Okay, so let me explain a little bit. A concept drift, it means that over time there will be a big change in your data. So for example, if you look at this picture, you will see that some products like the apple made not so much money, but at some point in time the utility increased a lot. So it could be, for example, maybe on the TV, okay, television. Maybe some people say these apples are very, very good, and then everyone start to buy these apples and so on. So how to solve the problem? We use a sliding window, two windows, and we use some statistical test to see if there's a change in the data that is significant to find the concept drift. Okay, so that is all I will say about this one. Okay. Another problem with the time we studied in another paper is to find the peak high utility item sets. Okay, what is a peak? It means in your data the money will increase a lot for some products during some period of time. Okay, So I give you some example. Here in China, the people buy a lot the moon cakes. Some cakes you can see on the picture. Okay, it is very sweet, but they don't buy this during the whole year. They will buy this only during some holiday. Okay, at some point in time during the year. So normally people don't buy, but there will be a peak in the data during some special period of time. So we designed some algorithm to find this automatically. It can look in your data and find the peaks in your data for the utility. So how we do this? Just the basic idea. We use the moving average crossover, like for the stock market, and this allows us to find the place it increase and decrease, and to identify the peak in the data. Okay, other problem we can do with the time is to find the trends in the data. For example, here have a look at this picture. Okay, we see that there is some increasing trend during some time interval in time. So maybe some products is becoming more and more popular. Okay, so there is an increasing trend. Another topic that is interesting is to find the periodic patterns. It means to find something always appear in your data, always repeating in your data. For example, if we look at the shopping data, maybe we can find that some people always buy the wine with the cheese every week. Okay, so this type of pattern is very, very interesting because it tells you something about the habit of the customer. So if you know someone always buy wine and cheese every week, then maybe you can do some recommendation or give a discount to try to earn more money. But also it helps you to understand the data when you find this type of pattern, the periodic patterns. Okay, so we designed some algorithm to solve that problem also. Another thing we can do with the time is to find the stable patterns or unstable. Okay, so for example, for the periodic pattern, we want to find something always repeat over time. People buy the wine and cheese more or less every week. So stable means a periodic pattern is stable if it always appears about every week, always about the same time interval, like 1 week, every week. Okay, but unstable, what does it mean? It means maybe the pattern appears every week, but later it does not appear for a few months. Okay, then it appears every week, then it does not appear for several weeks, and so on. So this is unstable because the behavior change over time is not always the same. So we designed some algorithm also to solve that problem. Okay, and that paper actually received the best paper award at this conference. Okay, the IEA-AIE conference. Okay, so all of this is interesting, I think, but there is some other things we can do also. I want to show you some other problems, okay, to give you some overview. So another limitation of the high utility item set mining is that normally we don't consider the categories of products, but in the real life you have some categories. For example, there are different types of milk. Okay, so you could have one type of milk, another type of milk, and so on. But all of them, they are the milk. So if you have different items like A, B, C maybe could all be the milk or could all be the food. So if we know the information about the categories of item, this is very interesting. So here in this problem we call the cross-level high utility item sets. We want to find the sets of items make a lot of money, but also we want to search for the categories of products. Like if you buy milk, any kinds of milk with any kind of bread, it makes a lot of money. Not just one type of milk, any types of milk. Okay. So the input, the data, is two tables as I showed you before, the transactions and the profit. Okay, but now on the right we have also a taxonomy. It is like a tree. The taxonomy, it is some categories for the items. So we have the category like X. In the category X, like food, we have two subcategories like Y and we have C. Okay, so maybe in the category food, the category Y means the milk, and then A and B are two types of milk, and so on. And then the result, we find the item sets that make a lot of money and can be the categories, and so on. Okay, so this is just to give you a brief idea about this. Okay, I will not go into details. I just want to show you some interesting problems we can do. So for example, we apply this type of algorithm on the real data, the shopping data from the US, and we find that the people like to buy the beans and the cherries together. So beans and cherries, they are the categories. Okay, so if you buy the bean, it can be any types of beans, like the baby beans, the green beans, and so on. And any types of cherries, people like to buy this and it makes a lot of money. So this was found in the real data. Okay, so there are also many other types of data we can study to find the patterns. Here I give you another example, a little bit different. Okay, so here another problem we call the frequent episode mining. The input here is a little different. It is a sequence of events. So here you have different timestamps like T1, T2, T3, and so on. And we have some events, like at time 1, we observe some events like AC. Time 2, we observe the event A, and so on. Okay. So now what we want to find is some events that often appear together over the time. So let me show you the result. Okay. Here we set, for example, we want to find what we call the episode. So the first one at the bottom means A, B together appear 2 times. Okay, because we have A, B together at time 3 and at time 7. Okay, A and B together. The second line of the output means A before B. Okay, so at some point in times we have A before B, like T2 and T3, we have A before B. T6 and T7, we have A before B, and so on. So I don't want to go into details about this, okay? Because there are more details actually. We also have a window of time in this. But the main idea about this is you have a sequence of events and you want to find the patterns about the events that appear before some other events to learn something from your data. Okay, so I will skip some details. Also, other things we can do. We can analyze the graph also. So here I show you briefly an example. On the left I have a graph database. It is a database of three graphs. Graph 1, graph 2, graph 3. And we want to find the subgraph appear in many graphs on the left. Okay. So here we design some algorithm to find the top subgraph, the top 3, okay, in my example. So I want to find the subgraph that appear the most often in this database, the top 3 subgraph. So the result will be like this. I find 3 subgraphs, and these are the subgraphs appear the most often in the database on the left. For example, if we look at the subgraph 3, I have highlighted in red color where it appears on the left. Okay, so you can see it appear 3 times. So this is a problem we can use to analyze the graph. Okay, like the chemical molecules and so on. So why I talk about this, okay, is just to show you we can analyze different types of data, not just the shopping data, also the sequence or the graph and other things. So now I give you some broad introduction about pattern mining. I show you many interesting topics, what we can do. So what are the current challenges in this field? First, one interesting research direction is to design the more efficient algorithms, because these problems are not easy to solve. So maybe we need better strategies, optimization, and data structures to build the faster algorithms. We can use also the multi-thread GPU or the big data platform. Okay. Also, some other interesting challenges is to handle the more complex data. Like the data has more information. For example, maybe we have data about the customer profile and other things. So if we have more data, it will be more realistic. So I think making this more realistic is important to have more applications. And also we want to find the more complex patterns, like in the graph, the sequences, and so on. Also, we could design the new measure to find the interesting patterns, not just the support and utility. And also, we can design some new applications, not just for shopping, and we can also look at many other things. So, currently, what are the trends in this field? I observe that there are many papers in top conference about finding patterns that are statistically significant using the statistical test. So this is one interesting research direction. Also, I see many papers about the data streams. Another topic is also to design the algorithm that are parameter free. Okay, don't have parameters or very few parameters to make it easier to use. So this is some trends. Also, I think another important trend is to combine the pattern mining with the machine learning, okay, ML, machine learning. So, for example, we can use pattern mining to explore the data before we do machine learning, or to do the feature engineering. Also, we can use the patterns maybe to build the intelligence system or agents. Or we can also use the patterns to create the embeddings for the graph or sequence. Actually, I saw some paper have done this already. They find the patterns in the data and then use this to create some embeddings. You can use then for the machine learning and so on. So this is some promising research direction, in my opinion. Interesting. Okay, so I want to mention also briefly, I'm the founder of a data mining software called SPMF. If you want to do the pattern mining, you can look up for this, okay? On the web, you will find it, SPMF. It has now over 240, something like that, algorithms you can use to analyze the graph, the sequences, the transaction, and many other types of data. And also, the code is open source in Java, but you can use also from other languages, and it has the data set also. So if you want to do research with this, it's very easy. Okay. So this is the software you can see here. It is very simple to use. You can choose some algorithm, choose the data you want to analyze, and then choose the output, the parameters, and then you click run, and then you get the results. Okay, so this software we designed has been used in many applications, not just for shopping, but you can see here many applications like chemistry, music analysis, and many other things. So you can apply these techniques to many fields. Also, we edited several books I did with some other people. Two of them about pattern mining, you can see on the left, the high utility or periodic patterns. So if you are interested, you can have a look also. So that's all for my presentation today. I would like again to say thank you for having me to give a talk today. I wish you have a good conference, and if you have any questions or anything, feel free to contact with me or ask me. Okay, thank you so much.